In this scenario, I need to write a net ionic equation, sketch the particle diagram, and predict who's limiting in excess, all using volumes and molarities. So the very first thing I need to do is I need to, well, work out the net ionic equation. I know this guy's going to split here and here. This is a strong base, that's a strong acid. I'm going to leave the water alone. He does not dissociate in these net ionic equations, but the NaCl will because of how soluble it is. And then I can remove some of the net ionics or some of the spectator ions. So sodium would be removed because he's a spectator. On top of that, chlorine shows up as dissociated on both sides of the equation. So if I had to rewrite this as a net ionic equation, all that would be left would be the OH minus aqueous reacting with the H plus aqueous, making me water, which will be a liquid. So my diagrams are going to reflect this chemical reaction right here. I'm not going to see a lot going on with the NAs and CLs, and we'll talk more about that in a minute. Now, let's get back to the quantities of things. In order to do this, I need to know how much NaOH and how much HCl are actually reacting. I've got volumes and molarities, and if you remember, you can use dimensional analysis to find moles. So I'm going to take the milliliters here. I'm going to convert milliliters into liters. And then I'm going to convert liters into moles using that molarity right there, which, by the way, will give me moles of NaOH. Now, if I type this in, I'm going to get 25 milliliters up top. There are 1,000 milliliters inside of 1 liter, and then 1 liter contains that many moles, 0.20 moles of NaOH. If I type this in on my calculator, multiply the top, divide by the bottom, you get a final answer of 0.0050 moles of NaOH. Okay, so let's come over here and do the same with this guy. All right, I'm starting out with milliliters again. In fact, it's going to look pretty much the exact same. I'm going to go from milliliters to liters. I'm going to go liters to moles, but this time, because I'm using that molarity right there, it's going to be moles of HCl. And I've still got 25 milliliters of that one. There's still 1,000 milliliters inside of 1 liter. That never changes. And then 1 liter, that changed. I've got a different molarity, so there's a different number of moles in every liter this time. And if you multiply that one out, you get 0.0025 moles of HCl. And this is important because the first thing you should notice is that you've got twice as much sodium hydroxide as you do HCl. So when I draw my diagram right here, I'm going to draw twice as much NaOH for every HCl. So let's get to that. Now the problem is I'm not going to draw NaOH as NaOH. I need to show it as dissociated. Same with the HCl here. So what's going to happen? I said I'm going to have twice as much NaOH. Well, I'm going to draw an Na and an OH, give them their charges because they'll be dissociated. But I said there needed to be twice as much NaOH compared to HCl. Well, I can draw H plus and Cl minus just like this, and that would be a 1-to-1 ratio, where there's 1 NaOH for every HCl, but I need it to be 2-to-1, so I'm going to draw an extra NaOH floating around in here. And now I've got that 2-to-1 ratio in my drawing, reflecting the fact that there's twice as much NaOH as there is HCl, and yet they're still all dissociated. The NAs from the OHs, the Hs from the Cl minuses. Now, let's get to the actual part where we have a chemical reaction. The NAs are spectators, and so are Cls. So when we wrote our net ionic equation here, all that's happening is OHs are coming together with H pluses, so hydroxide with protons, to make water. So I'm going to go over here and I'm going to find myself a hydroxide. I'm going to find myself a proton. I'm going to cross them out, and I'm going to use them to make water over here. Ta-da! And the problem is, that's all that can happen. These NAs are spectators. The Cl here is a spectator. And the OH isn't a spectator, but he has no one to react with. There's no H pluses floating around in here. So you're going to draw all of these guys over here just floating around, doing what they do. So 2 of the Na pluses, and then a Cl minus, and then one of the OHs who never got a chance to react. Poor hydroxide. And here's the deal. This tells me who actually ran out. Now you could say H plus is the thing that's limiting you, because he's actually the guy that's reacting. But in the equation, he was written as HCl, so you could say either one. You could say H plus or HCl is limiting. In other words, they ran out. And then the thing that's in excess, the thing you have more of than you actually need, is sodium hydroxide. Or alternately, you could say OH minus is the thing that you had too much of. So is in excess. And that's it.